Hari Om. Hello everyone, I am Sri Jyoti. Welcome back to my channel. In this video, let's go through some important case study questions based on applications of derivatives. First question, the fuel cost per hour for running a train is proportional to the square of the speed it generates in kilometer per hour. If the fuel cost rupees 48 per hour at the speed 16 kilometer per hour and the fixed charges to run the train amount to rupees 1200 per hour. Based on this information, questions. First question, given that the fuel cost per hour is k times the square of the speed the train generates in kilometer per hour, then what is the value of k? It is already given that fuel cost per hour is proportional to the square of the speed of the train. Okay, so let the speed of the train be v kilometer per hour. Okay, then it is given that fuel cost is equal to, that is, it is proportional to, right, proportional to speed of the train, and in first question it is given the fuel cost per hour is k. Okay, k times the square of the speed, so k into v square. Okay, now, and it is given we have to find the value of k when, see, here it is given fuel cost rupees 48 per hour at speed 16 kilometer per hour, that is fuel cost is 48 is equal to k into v is, what is the speed, 16 kilometer per hour, that is 16 square. That implies k is equal to 48 divided by 16 into 16, right? So here 4 4s are 4, 12, 4 4s are 4 3s are, so it is equal to 3 divided by 16. Therefore, the value of k is 3 divided by 16. Second question based on above information. If the train has travelled a distance of 500 km, then the total cost of running the train is dash. So here we know that total cost of running the train is equal to fuel cost plus fixed rate, right? That is fixed charges. Fixed charges into time, right? Okay. Now that is equal to fuel cost. It is given that fuel cost is proportional to square of the speed, and we have found the value of k also, right? That is, we have got fuel cost is equal to 3 by 16 into v square. Okay, here also v is the let's denote speed as v. Okay, so fuel cost is equal to 3 divided by 16 v square, right? So 3 by 16 v square plus, what is the fixed charge? It is given fixed charges to run the train amount to rupees 1200 per hour. Okay, so here 1200 into t. Okay, now for 500, here we have to find the total cost for distance of 500 km, right? And we know that speed formula, that is speed is equal to distance divided by time, right? So here distance is 500 km time t. Okay, now what is t? T is equal to 500 km divided by v. Substitute this one here, so we will get 3 divided by 16 v square plus 1200 into 500 divided by v. It is the total cost. Okay. Now, 1V cancelled. So, it will be 13 divided by 16. Sorry, 3 divided by 16 into 500 V. Okay, 1V cancelled. Plus 1200 into 500, that is 4 zeros, right? Divided by V. That is equal to 1500 V divided by 16 plus 6 lakh divided by V. It is the total cost in function of V. Third question is, what is the most economical speed to run the train? We have total cost of the train. Total cost of the train C is equal to 1500 divided by 16 V plus 6 lakh divided by V. Right? Now this can be reduced. 4 4s are 16. 4 3s are 4 7s are 28, 4 5s are. So 375 divided by 4 V plus 6 lakh divided by V. Okay. Now for economical speed of the train, dC divided by dV is equal to 0. Rate of change of total cost with respect to the speed, that is equal to 0. That implies, find the derivative of this one with respect to V. So here first term is 375 divided by 4. Here derivative of 1 by V is minus 1 by V square. So this plus will become minus. Minus 6 lakh divided by V square. Okay. Then it is equal to 0. That implies 375 divided by 4 is equal to 6 lakh divided by V square. That implies V square is equal to 6 lakh into 4 divided by 375. 375. Reduce it. So it will be 5 7s are 35, 5 5s are 25, 5 12s are. Okay. Next, 5 15s are here. 5 1s are 5 2s are 10, 5 4s are. After that again 5 3s are. So here it will be 5 4s are 20, 5 8s are. Okay, again 3 cancelled, 16,000, right? Sorry, 1,600. 1,600. 1 0 reduced. Okay. So here it is V square. We have got V square is equal to 1,600 into 4. We have to find V, right? So V is equal to square root of 1,600 into square root of 4. Square root of 1,600 is 40, right? Into square root of 4 is 2. That is equal to 80 kilometer per hour. That is, the most economical speed of the train is 80 kilometer per hour. Fourth question. The fuel cost for the train to travel 500 kilometer at the most economical speed is dash. See here, we know that fuel cost is equal to, in this question it is given that fuel cost per hour is proportional to the speed of the train. That is speed kilometer per hour. Okay. So here fuel cost we can write fuel cost is equal to K value is 3 by 16 into V square into T. Okay. Here, because this fuel cost will change when T changes. Right. Here it is, time is not given. We have to find for 500 kilometer what is the time taken. Okay. So, for 500 kilometer, we know that V is equal to, that is speed of the train, that is equal to distance divided by time. Right. That is 500 kilometer divided by T. That implies T is equal to 500 divided by V. Right. So, let's substitute T here. Therefore, fuel cost is equal to 3 by 16 into V square into 500 divided by V. V cancelled. So, 3 into 5 is 15,500 divided by 16 into V. Reduce it. It is equal to, we have already got 375 divided by 4V. Okay, so it is the fuel cost. And our question is, what is the fuel cost for the train to travel 500 kilometer at the most economical speed? So, what is the most economical speed of the train? We have already found in third question, right? So, most economical speed of the train is 80 kilometer per hour, right? Now, what is the fuel cost of the train to travel 500 kilometer at the most economical speed? So, substitute here V is equal to 80 kilometer per hour. That is, so here fuel cost is equal to 375 divided by 4 into 80. That is equal to 20. Okay. So, here it will be 0, 10, 15, 7,500 fuel cost, that is rupees. Okay, rupees 7,500 is the fuel cost. Fifth question, the total cost of the train to travel 500 km at the most economical speed is dash. In second question, we have already found the total cost of the train to travel 500 km, right? So, that is the total cost for 500 km is, we had got 375 divided by 4 into V plus 6 lakh divided by V, right? And here we have to find the total cost of the train to travel 500 km at the most economical speed. What is the most economical speed of the train? That is 80 km per hour. Now here substitute V is equal to 8. Therefore, the total cost of the train to travel 500 km at the most economical speed is 375 divided by 4 into 80 plus 6 lakh divided by 8. That is equal to, it is 7,500 plus 1 0 cancelled, 8 1s are 8, 7s are 7,500. 7,500 plus 7,500, that is 15,000. So, it is the total cost of the train to travel 500 km at the most economical speed. An architecture design an auditorium for a school for its cultural activities. The floor of the auditorium is rectangular in shape and has a fixed perimeter P. Based on the above information, solve the following questions. First question. If x and y represents the length and breadth of the rectangular region, then relation between the variable is. Very simple, right? See here, in all the equations P is there. P is nothing but perimeter, and we know that perimeter of the rectangle is 2 into length plus breadth, right? That is 2 into x plus y. It is given x is the length of the rectangular region and y is the breadth, right? Therefore, 2 into x plus y is equal to p. So, C is the correct answer. Second question is, what is the area A of the rectangular region as a function of x? Here we know that the area of the rectangle is length into breadth. That is, here length and breadth are x and y. So here A is equal to x into y. Therefore, A is equal to x into y. But here we have to express this area as function of x. Okay. So here, so substitute what is y. We know that 2 into x plus y is equal to p. Right. That implies 2x plus 2y is equal to p. That implies 2y is equal to p minus 2x. That implies y is equal to p minus 2x divided by 2. Right. So let's substitute this y here. That is, A is equal to x into p minus 2x divided by 2. That is equal to px minus 2x square divided by 2. So it is the area of the rectangular region as a function of x. Third question. School's manager is interested in maximizing the area A. For this to be happen, what should be the value of x? In maxima and minimum, that is in applications of derivatives, we have studied that at which point the given function is maximum and minimum, right? Here we have to find at what value of x, at what value of x the area of the rectangular region is maximum. Okay, so for that we have to write the area function of x should be expressed as a function of x, right? So A is equal to, in second question we have got A is equal to, that is function of x, px minus 2x square divided by 2. Now we know that to find the value of x means to find the maximum or minimum, we have to take derivative is equal to 0. That is, dA by dx is equal to 0, right? So for maxima and minimum, here maximum, right? For maximum, dA by dx is equal to 0. That implies we have to differentiate it. That is 1 by 2 into left side dA by dx. dA by dx is equal to p into, that is 1 by 2 into p, derivative of px is p, minus 4x, that is equal to 0. Okay. That implies p minus 4x is equal to 0. That implies p is equal to 4x. That implies x is equal to p by 4. Okay. So here our question was, at what value of x this area of the rectangular region is maximum. So here at x is equal to p by 4, the area of the rectangular region is maximum. So here the answer is p by 4. Next question is, the value of y for which the area of a floor is maximum is dash. So here, when the area of the floor is maximum, then what is the value of y? We know that at x is equal to p by 4, the area is maximum, right? Therefore, let's substitute x is equal to p by 4 to find the value of y. Here we know that 2x plus 2y is equal to p. That implies y is equal to p minus 2x divided by 2, right? So in this, we will substitute x value. So here we have already found at x is equal to p by 4, the area of the floor is maximum, right? Therefore, the value of y is equal to p minus 2 into p by 4 divided by 2. That is equal to p minus p by 2 divided by 2. That implies p by 2 divided by 2, that is p by 4. So y is also p by 4. Fifth question, what is the maximum area of the floor? We have found that at x is equal to p by 4 and at x is equal to p by y is equal to p by 4, the area of the floor is maximum, right? So here we have to find maximum area of the floor. So for that, let's write the equation of the area. That is, A is equal to, we know that the length into breadth, that is x is equal to x into y, A is equal to x into y, or you can write A is equal to in function of x only, okay? So here let's write A is equal to x into y, because we know that y is equal to p by 4, the area of the floor is maximum, right? So we can substitute the value. So here x is equal to p by 4, area of the floor is maximum, and at y is equal to p by 4, area of the floor is maximum, we have already found. So here A is equal to x into y, that is p by 4 into p by 4 is equal to p square divided by 16. Therefore, maximum area of the floor is nothing but p square divided by 16. Third question. The relation between the height of the plant, y in centimeter, with respect to its exposure to the sunlight is governed by the following equation. Y is equal to 4x minus 1 by 2x square, where x is the number of days exposed to the sunlight. For x less than or equal to 3. Okay. Based on the above information, solve the following equations. Let's see what is the first question. Find the rate of growth of the plant with respect to the number of days exposed to the sunlight. So here we know that the growth of the plant is denoted by y, right? And with respect to the number of days exposed to the sunlight is denoted by x, right? So here we have to find dy by dx. What is dy by dx? We have an equation, right? Y is equal to 4x minus 1 by 2 x square. What is dy by dx? Derivate, differentiate it with respect to x. That is dy by dx is equal to, derivative of 4x is 4 minus 1 by 2 into derivative of x square is 2x. That is equal to 4 minus x. So it is the rate of growth of the plant with respect to the number of days exposed to the sunlight. In this second question, does the rate of the growth of the plant increase or decreasing in the first 3 days? What will be the height of the plant after 2 days? See, here we have already learnt that increasing and decreasing function, right? And we know how to check whether the given function is increasing or decreasing. We learned that if f dash of x is greater than 0, then f of x is increasing. If f dash of x is less than 0, then f of x is decreasing, right? Okay, so here let's check what is our function. Here our function is y is equal to 4x minus 1 by 2 x square, right? So here y is equal to 4x minus 1 by 2 x square. Now let's find dy by dx. That is rate of growth of the plant. Okay. So here dy by dx. That will, see here we have to check the rate of the growth of the plant increasing or decreasing. That means that is nothing but dy by dx here, right? So dy by dx is equal to, we have already found 4 minus x, right? And here it is mentioned the rate of the, does the rate of the growth of the plant increase or decreasing in the first 3 days? Number of days is denoted by x, right? So here x is less than or equal to 3. X is equal to 1. Possible values of x are x is equal to 1, x is equal to 2, x is equal to 3, right? So for x is equal to 3, that is here for x less than or equal to 3, it is greater than 0, right? When x is equal to 1, 4 minus 1, 3, that is greater than 0. When x is equal to 2, 4 minus 2, 2, that is greater than 0. For x is equal to 3, 4 minus 3, that is greater than 0. So here dy by dx is greater than 0 for x less than or equal to 3. Therefore here this function is increasing function in the first 3 days. Means it is an increasing function for x less than or equal to 3. Or here we can say the rate of growth of the plant increasing in the first 3 days. Okay, the rate of the growth of the plant increasing in the first 3 days. So here next, another question is here. What will be the height of the plant after 2 days? See, here it is given the relation between the height of the plant and with respect to its exposure to the sunlight. Okay, is governed by the following equation. So, it is the equation y is equal to 4x minus 1 by 2 x square. Here x is the number of days. Right? So, here we have to find the height of the plant after 2 days. Means when x is equal to 2, what is y? Okay. So, here equation of the plant, that is y is equal to 4x minus 1 by 2 x square. Okay. Here y is the height of the plant, x is number of days. So, when x is equal to, substitute x is equal to 2, we will get height of the plant. Right. So, here when x is equal to 2, y is equal to 4 into 2, 8 minus 1 by 2 into 2 square, 4. That is equal to 8 minus 2, 6. So, here y is in centimeter, right? So, 6 centimeter. Okay. So, here height of the plant is height of the plant after 2 days is 6 centimeter. Next, fourth question. P of x is equal to minus 5x square plus 125x plus 37,500 is the total profit function of a company where x is the production of the company. Here, it's an equation of the total profit of a company. Okay. And here in this x is the production of a company. Okay. Now here, let's see what is the first question. First question is, what will be the production when the profit is maximum? That means we have to find at what value of x given function is maximum. Okay, at what value of x given function is maximum. So here we have learned for maxima and minimum, we have to take the method. The first process is for maximum or minimum. The first method is dy by dx is equal to 0. That means here dp by dx. Okay, that is derivative of this function with respect to 0. That is dp by dx is equal to 0. That implies, see here differentiated with respect to x, minus 10x plus 125 is equal to 0. That implies 10x is equal to 125, right? That implies x is equal to 125 divided by 10, that is 12.5. So here x is equal to 12.5. And next let's check whether this function is maximum or minimum. So for that, let's find the second derivative of the function. That is d square p divided by dx square. That is equal to minus 10. That is less than 0 for all x. So here we can say at x is equal to 12.5. Okay. So this function is maximum. Since it is d square, that is second derivative of given function is less than 0. Therefore this function is maximum at x is equal to 12.5. So here our question is, what will be the production? Means value of x when the profit is maximum. So the answer is 12.5. Okay. So at x is equal to 12.5, P of x is maximum. P Second question is, what will be the maximum profit? Here in first question, we have already found that at x is equal to 12.5, given function is maximum. That is, the total profit of a company is maximum when x is equal to 12.5. So here, by substituting x is equal to 12.5 in the equation of a profit of a company, we will get the maximum profit, right? So here, equation of total profit of a company is P of x is equal to minus 5x square plus 125x plus 37,500. Substitute 12.5, x is equal to 12.5 plus 125 into 12.5 plus 37,500. Okay, so here minus 5 into 156.25 plus it will be 156.2.5 plus 37,500. That is equal to, see, after calculation we will get 38,281.25 rupees. So the maximum profit is rupees 38,281.25. So next is, when the production is 2 units, means when x is equal to 2. Okay, because here x denotes the production of the company, right? So when x is equal to 2, what will be the profit of the company? Just substitute x is equal to 2 here. So when x is equal to 2, what is P of x? Minus 5 into 2 square 4 plus 125 into 2 plus 37,500. That is equal to minus 20 plus 250 plus 37,500. That is equal to, here it will be 37,500, 500 plus, that is 750 minus 20, that is equal to 37,730, right? So here the total profit when the production is 2 units is rupees 37,730 rupees. Third question is, find the interval in which the profit function is strictly increasing. So here we have to find the interval in which the given function P of x is strictly increasing. For that we have to find the points, critical points, right? So for that, first of all we have to find the P dash of x, that is derivative of given function with respect to x. P dash of x is equal to minus 10x plus 125. Take minus 10 outside, so minus 10 into x minus 12.5. Okay, so here see, when x belongs to minus infinity to 12.5, minus infinity to 12.5 means the values of x less than 12.5, this P dash of x is less than 0 or greater than 0. See here, let's check. See, when x less than 12.5 means minus infinity to 12.5, that means x less than 12.5. So just let's take any value, when x is equal to 10. If x is equal to 10, it will be minus, right? 10 minus 12.5, that is minus 2.5. This minus into minus will become plus, right? So here, if you substitute any values of x less than 12.5 or in the values of in this interval, we will get this P dash of x greater than 0. This one minus, minus into minus, plus. Suppose x is equal to minus 2. Minus 2 minus 12.5, it is minus, right? Minus into minus will become plus. So here P dash of x is greater than 0 when x belongs to minus infinity to 12.5. What about 12.5 to infinity? If you substitute any values of x greater than 12.5, this inside the bracket will be positive, right? Positive into negative, that will be negative, right? So it will be less than 0. Here we have to find the interval in which the profit function is strictly increasing. Strictly increasing means that p of x, p dash of x should be greater than 0, right? So here when p dash of x is greater than 0, only when x belongs to minus infinity to 12.5. So it is the interval. Okay. In this interval, the profit of the function is strictly increasing. Or we can write when x belongs to minus infinity to 12.5, p of x is strictly increasing. That is, the profit, total profit is strictly increasing when x belongs to minus infinity to 12.5. Look at the next question. In an elliptical sport field, the authority wants to design a rectangular soccer field with the maximum possible area. The sport field is given by the graph of x square by a square plus y square by b square is equal to 1. So next, first question based on the above information. If the length and breadth of the rectangular field are 2x and 2y respectively, then find the area function in terms of x. See, here it is given that equation of an elliptical sport field is x square by a square plus y square by b square is equal to 1. Okay. Suppose it's our ellipse. Okay. It's an elliptical sport field and this length, that is a is the length of the semi-major axis and b is the length of the semi-minor axis, right? So this length is a, it is b, and it is given that length and breadth of the rectangular field, so is length and breadth of the rectangular field are 2x and 2y. So it is 2x and it is 2y. Okay, we have to find the area in terms of x. And we know that area of the rectangular field is length into breadth, that is 2x into 2y, that is equal to 4xy, right? Now here we have to convert this y to x because we have to write the area function in terms of x, right? So from this we will get y. Okay, so this implies that is y square by b square is equal to 1 minus x square divided by a square. That implies y square is equal to b square into 1 minus x square by a square. Okay, that is equal to, take LCM here. So it will be b square divided by a square into a square minus x square, right? So this implies y is equal to b by a root of a square minus x square. Okay, now let's substitute this y is equal to b by a root of a square minus x square in this area. Okay, therefore area of the rectangular field is equal to 4x into b by a root of a square minus x square. So it is the required area. Next question, find the critical point of the function. That is, a function means area function. Okay. So in first question we have got area is equal to 4 into b by a x root of a square minus x square, right? That is 4b by a x into root of a square minus x square. Okay, it is the area function. So here we have to find the critical point. We know that to find the critical point we need to find a derivative. Okay, that is dA by dx. dA by dx is equal to 4b by a is constant. 4b by a into two functions are there. So apply product rule. X into derivative of root of a square minus x square is 1 by 2 root of a square minus x square into minus 2x, right? Plus root of a square minus x square into 1. Okay. Next, let's simplify this one. It is equal to 4b by a. It is 2 cancelled, right? So minus, it is minus 2x, right? So minus x square divided by root of a square minus x square plus root of a square minus x square. Now take LCM, that it will be 4b divided a, because here we have to find the critical point, right? So to critical point we have to make it in the form of factors. Okay, that is we equate dA by dx is equal to 0 to find the critical point. So for that we have to simplify and make it in the form of factors. Okay, so 4b by a, here take LCM, so minus x square plus root a square minus x square into root a square minus x square, it will be a square minus x square divided by root of a square minus x square, right? Now it will be 4b divided by a square minus 2x square divided by root of a square minus x square. Okay, now this can be written as, see here, let's take minus 2 outside. Okay, it is equal to 4b divided by a, take minus 2 outside, so it will be minus 8. Okay, so minus 2 taken outside, so here it will be, it is plus, right, because minus taken outside. So x square minus 2 taken outside, therefore it will be x square, and it is minus a square by 2 because we have taken minus 2 outside. Okay, divided by root of a square minus x square. Okay, now it is factorized. It can be factorized. Okay, so it is equal to minus 8b divided by a. It's in the form of a square minus x square, right? Or x square minus a square. That is x plus a by root 2. Okay, into x minus a by root 2. That is a square minus b square is x plus a into x minus b, right? Divided by root of a square minus x square. To find the critical point, dA by dx is equal to 0. So dA by dx is equal to 0 implies this one is equal to 0. This expression is equal to 0 implies these factors. Okay, this will we can take this one right side, it will be 0, and take this constant right side, it will be 0. So here remaining it will be x plus a by root 2 into x minus a by root 2 is equal to 0. That implies here we will get x is equal to minus a by root 2 and x is equal to plus a by root 2, right? So here x is equal to see x is nothing but its length, right? So x is equal to minus a by root 2. It is not possible, right? X is equal to minus a by root 2 is not possible since x denotes the length. Okay, so here length of the, that is 2x is the length of the rectangular field, right? So here x is equal to minus a by root 2 is not possible. Therefore x is equal to a by root 2 is the critical point of the function. Next question, use first derivative test to find the length 2x and width 2y of the soccer field in terms of A and B so that maximize its area. See, here we have to find the length and width of the rectangular field, that is soccer field, so here, so that its area should be maximum. Okay, so for that, so and using first derivative test. Okay, it is mentioned using first derivative test. So for that we need to find dA by dx, right? So here we know that a is equal to 4b by a x into root of a square minus x square, right? And here we have already found the critical point, right? That is critical point x is equal to a by root 2. Okay. And here what is that dA by dx? dA by dx, that is equal to, we have already found, right? That is 4b by a into a square minus x square divided by root of a square minus x square. We have already found it in last question. Okay, so here dA by dx is equal to 4b by a square minus 2x square by root of a square minus x square. It is the first derivative. Okay, so and we have got x is equal to a by root 2. And when we substitute x is equal to less than a by root 2, any values less than a by root 2 in this dA by dx, obviously it will be greater than 0. If we substitute x is equal to a by root 2, it will be 0, right? And it is less than, if x is equal to less than a by root 2, then see here we will get a square, it is greater than, right? Greater than this term, right? So it is greater than 0. So and when x is equal to greater than a by root 2, okay? See here d by dx is greater than 0 when x is less than a by root 2. And when x is greater than a by root 2, then see when we substitute any values greater than a by root 2, this will be negative, right? That means dA by dx is less than 0. dA by dx is less than 0 when x is greater than a by root 2. Here x is equal to greater than a by root 2 means it is very close to a by root 2. Okay, it is close to a by root 2 and less greater than a by root 2. Okay, so in that case dA by dx is less than 0. So according to the first derivative test, we can say there is a local maximum at the point x is equal to a by root 2. Okay, therefore here area is maximum when x is equal to a by root 2. Now we have to find the length and width of the rectangular field, right? So length 2x is equal to 2 into a by root 2, that is a into root 2, right? Next 2y, here y we have to substitute x value, right? So first of all we have to write this in x terms. So 2 into b by a, we will get y in this equation. From this equation we will get y. So 2 into b by a root of a square minus x square, right? That is equal to 2 into b by a, here it will be root of a square minus x is equal to a by root 2. Substitute x is equal to a by root 2, a square by 2. So a square minus a square by 2, that is equal to 2 into b by a, it will be 2a square, take LCM. So 2a square minus a square, root of a square a. So a divided by root 2, right? So a cancelled, root 2 cancelled. So root 2b. So here length of the rectangular field, soccer field, a root 2a, and width of the soccer field root 2b, so that its area is maximum. Okay, it is the answer. Next question, use second derivative test to find the length 2x and width 2y of the soccer field in terms of A and B that maximize its area. Same question. Okay, here also we have to find the length and width of the soccer field so that its area should be maximum. Okay, so here we have to find, the method is, see here we have to apply using second derivative test. Okay, so for that here we need to find the second derivative, right? So therefore See, after finding the first derivative, to find the second derivative, it will be complicated, right? So let's square it on both sides. Okay, that is a square is equal to, because we know that if a square is maximum, a is also maximum. Okay, so a square, let's take it z. Okay, z is equal to a square, that is equal to 4b by a, that is square it. Okay, 16b square by a square, x square into a square minus x square. Okay, that is equal to 16b square by a square multiply a square into x square minus x raised to 4. Okay, now let's find the first derivative dz by dx. That is equal to, here 16b square divided by a square into derivative of this one, here 2a square x minus 4x cube. Okay, it is the first derivative dz by dx. And find the critical point. We know that critical point x is equal to a by root. Okay, let's find dA by, that is dz by dx is equal to 0 implies 16b square divided by a square into 2a square x minus 4x cube is equal to 0. Okay, after simplifying, you will get x is equal to a by root 2. That is the critical point. Okay, here we have to use second derivative test, right? So, therefore, let's find the d square z by dx square, whether it is this function maximum or minimum. Okay, so here d square z by dx square is equal to, let's differentiate it again with respect to x, 16 b square by a square, here it is 2a square, derivative of x is 1, so 2a square minus 12x square. Okay, so it is d square z by dx square. Now we have to check whether this d square z by dx square less than or greater than 0 at this point. Okay, now let's check. So substitute at x is equal to a by root 2 d square a by dz square, sorry dx square. It is not d square a, d square z. Okay, that is equal to 16b square divided by a square into 2a square minus, substitute x is equal to a by root 2. So 12 into a square by 2. A square by 2. That is equal to 16b square divided by a square, 2a square, it is minus 6a square. So it is, we will get minus because 4a square minus 6a square, that is minus 4a square. So it will be minus 4 into 16, 64 b square, a square will be cancelled. So it is less than 0. Okay, b is always greater than 0. Okay, because it is the length. So minus 64 b square. If b is negative also, it will be positive, right? B square. So minus 64 into b square, it is less than 0. That means according to the second derivative test, this area is maximum at x is equal to a by root 2. Okay, the area A is maximum at x is equal to a by root 2. Here we have to find the length and width of the soccer field so that its area is maximum. Okay, that is length and width of the soccer field so that its area is maximum. So here we have found that this, according to the second derivative test, this area is maximum when x is equal to a by root 2. Okay, so here let's find length and width of the soccer field. So 2x, length of the soccer field is 2x, 2 into a by root 2, that is equal to root 2 into a. Okay, and 2y is equal to 2 into b by a root of a square minus x square. So here also apply x is equal to a by root 2, we will get root 2b. Okay, so length of the soccer field is root 2a and width of the soccer field is root 2b, so that its area is maximum.